Hey, welcome back to another video on triangle isometries and similarity. This one is on proving whether triangles are congruent or not. Let's have a look. Okay, when we say that triangles are congruent, all we're saying is that the triangles are exactly identical to each other in every way possible, meaning they have the exact same side lengths and the exact same angles as each other. Now in this course, we might be asked to prove whether triangles are congruent or not. And to do this, we're going to rely on three proofs that we can use that will confirm that triangles are congruent. The first one I'm putting on the screen here is called the SSS, or side-side-side proof. The second one is called SAS, or side, angle, side. And the third one is called ASA, or angle, side, angle. Now it's really important that you have those letters in the right order. In the last two proofs, side, angle, side, and angle, side, angle, it's important that those letters are kept and used in that order. I'm going to get to that in just a moment. First up, let's talk about that first proof. It says side, 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 and what it means is if we have triangles that have identical side lengths to each other, then those triangles are definitely congruent, meaning there's only one way to draw a triangle with three side lengths that match the three side lengths of another triangle. So remember I just told you that congruent means identical in every way? Well, as long as we know that three side lengths are the same, there's only one way to draw those triangles, and the angles would have to be the same as well. Meaning that if three sides are the same, we have congruent triangles. So don't worry about how those triangles look or which way they're facing. They do this often just to throw us off. As long as you find a proof that works for congruence, then those triangles are congruent regardless of how they look. Now the second proof says that if two triangles share two pairs of sides that are the same length and the angle between those sides is exactly the same, then we definitely have congruent triangles. Notice how the proof is written side, angle, side, and when we write that, the angle is between the two sides. This is a big reminder that we need two side lengths that match on two different triangles, and the angle between those matching sides has to be exactly the same, and it has to be the angle between the sides. And if we have that information, then we know for sure that we have congruent triangles. We would use the SAS proof to confirm it. Now let's figure out right now how they're going to identify that angles are the same or not. Now the obvious case is if they give you a number for the angle and there's a number in another angle of another triangle that's the same, well then you know you have the same angle. The numbers match up. Now they might also identify an angle like we see here with an arc in it, or an arc with a line through it, or a double arc. Now anytime you see an angle identified the same as another one, it means those are identical angles. So in the same question, any angle with an arc through it is the same as any other angle that has an arc going through it. Those would be different though than angles with double arcs. Angles with double arcs are the same as each other, but different from the single arc angles. And those just mean, hey, look for another angle with this symbol and you'll find an angle that's exactly the same as this one. Now the third proof, angle, side, angle, is a lot like the second one, except what you need are pairs of identical angles with a side length in between those two angles that's exactly the same as the ones in another triangle. And if you have two angles the same with a side length between those two angles that's also the same, then you've got two triangles that are definitely congruent. The rest of the information, meaning the other angle and the other two sides, are going to be exactly the same in both triangles. So yes, these triangles are congruent using the ASA proof. Now the last little note that I want to leave you with here is that you might see the word necessarily congruent come up in a question somewhere. And they put the word necessarily in there because what we're looking at here are the minimum proofs. We're looking for the minimum amount of information that we need to prove whether two triangles are congruent or not. So if we're finding just the minimum amount of information, what we're saying is even though we only know this, it's necessarily true that these triangles are congruent based on this information. Side, 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 angle, side, or angle, side, angle are the three ways that you're going to prove whether triangles are necessarily congruent to each other. So now that we understand this concept of how to prove whether triangles are congruent or identical to each other, let's have a look at a couple of examples.